All right, so where do we use modular arithmetic in the real world besides clocks? We use it in barcodes. Maybe you need to take a moment, look at the back of your notebook, look at the back of your textbook. There are barcodes everywhere, and we use modular arithmetic. Let's look at an example. You have the flu and feel awful. You moan and groan, and you decide that you're going to call the Kleenex box on the back, 1-800-KLEENEX. Although you are extremely satisfied, you decide to dial the number, and the representative asks you to read the 12-digit barcode on the bottom of the box. You look, and everything kind of looks a little squiggly because you're not feeling well, and so you read these numbers to the person, and they say, actually, you made a mistake. Could you read them again? Now, you read them again and you realize that you actually reversed the 5 and the 1, but how did they know that there was a mistake? And the reason why is modular arithmetic. So, in a barcode, there are 12 or 13 digits, and the first 6 digits tell you about the manufacturer. They actually mean something. The first 6 digits actually mean something. This is the manufacturer. And the next 5 digits tell you about the product. So 1, 2, 3, 4, 5, these tell you about the product. Maybe it is 180 tissues or, 70 sheets on your notebook. The last digit is the check digit. And this is how you can determine if the number is correct or not. Now, these are all, algorithms and things like that, but we can do the algorithms by hand. So this is how it works for 12-digit barcodes. We're going to line up the first 11 digits of the UPC code, and we're going to call them like digit 1, digit 2, digit 3. So that's where they come from. And we're going to multiply every other number by 3 and add it all up. And then that last number is going to be the check digit. Now, at the end, we should get something equivalent to 0 mod 10. What does it mean to be equivalent to 0 mod 10? It means a multiple of 10. Okay, so we're going to check, let's check it out. So this is the correct Kleenex barcode. So this is our barcode. And so we're going to line it up, and I'm going to use a different color here. So we're going to line it up 0, 3, 6, 0, 0, 0, 2, 8, 5, 1, 9. And this is my check digit. Okay. And so now what I'm going to do is I'm going to multiply by 3 every other number. Times 3, times 3, times 3, times 3. But not my check digit. And I think I already made a mistake here. Let me see here. There's a 0. How did I know already? Because we should multiply by 3 right before. So you should always check. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 and our check digit. So now I'm going to actually do the multiplication. Well, that's 0, so that goes away. 3 plus 18, 0, don't care, 0, don't care, 0, don't care, plus 6, plus 8, plus 15, plus 1, 0, plus 9, my check digit. I'm going to add that always last. So now I'm going to add all these up, and I get, when I type that in my calculator, 51 plus 9 is my check digit. Is this equivalent to 0 mod 10? Well, what's 51 plus 9? That's 60. That is equivalent to 0 mod 10. It's a multiple of 10. So that is the correct barcode. Let's check the incorrect barcode. So these are the wrong digits here. I'm going to do the same thing. I'm going to multiply this by 3, 3, every other digit by 3. And then I'm going to add, that's the check digit. So now what happens? That's 0. 3 plus 18 plus, don't care, don't care, don't care, because zeros don't really help. 8 plus 3 plus 5 plus, okay, my check digit. So 3 plus 18 plus 6 plus 8 plus 3. Okay, so now I'm going to add these numbers up, and I get 43 plus 9 is my check digit. Is that equivalent to 0 mod 10? So that would give me 52. 52 is equivalent to 2 mod 10, right? Because that would be 50 plus 2. So this is incorrect. That's how we know it's incorrect. It doesn't equal to 0. So now there's actually some other ways that modular arithmetic work, and that is in checking checks. So if you were to look at a check from any U.S. bank, in the lower left-hand corner, you've got 9 digits. That is the bank identification number, but the last digit is a check digit. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That last digit is the check digit. So you've got 9 digits, and it's a little bit of a more complicated formula to figure it out. Again, algorithms do this, right? You know when you type in your routing number to pay a bill or something, and they say you entered it in wrong? This is how they know that you entered it in wrong, because they check this in the algorithm. You multiply the digits 739, 739, 739. So when you add up that sum, you should get 0 mod 10. So let's take a peek here. So again, your 8 digits are your bank ID. Your last one is your check digit. So let's look at this bank code here. All right. So we've got 211872946. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to multiply it. 739, 739, 739. But this is my check digit. I always deal with that last. So when we multiply this, it will be 14 plus 3 plus 9 plus 56 plus 21 plus 18 plus 63. I'm going to move that guy. Plus 12 plus, and look how I write this, 9 times 6. This is my check digit. I'm just going to deal with that at the end. So I'm going to add up all the other numbers, and I get 196 plus, and my check digit here multiplies to 54. Is that equivalent to 0 mod 10? And when I add those two up, I get 250, which is a multiple of 10. So this bank checks out. So you may want to pause this and try this first on your own, or you can watch me do it and then try it on your own later. They should not both say 1. Could this be a check number? So if we're talking about check numbers, it's going to be 739, 739, 739 check digit. Let's see. So that's going to be 7 plus 6 plus 0, 0, 3 plus 0 plus 7 plus 12 plus 9 times 3 check digit. So then when we add all those up, we get 29 plus 27, which gives us 56. Is 56 equivalent to 0 mod 10? No, 56 is actually equivalent to 6 mod 10. So that could not be a check number. So if you were to type that in to, a website, it would say error. All right, now this one's a little more complicated. Can you figure out the check digit? So we're going to do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're talking about checks. 739, 739, 739. So it's going to be 14 plus 3 plus 9 plus 56 plus 21 plus 18. There's so much space for error here, so go slow. Now look how I do this. Plus 9 times unknown. That's my check digit. When I add up all these other numbers, I get 196 plus 9 times unknown is equivalent to 0 mod 10. Now I'm going to guess and check this value. Okay, remember, it's a finite number. If this is 10, right, or this is a single digit, so it's going to be between 0 and 9. So let's try 0. So if I plug in 0, it would be 196 plus 0. 196 would give me 6, not 0. So let's try 1. What's 196 plus 9 times 1? That would give me 205. That would be a remainder of 5. Let's try 2. 196 plus 9 times 2 would give me 214. That would be a remainder of 4. Let's try 3. That would be 196. So what I'm doing here is 196 plus 9 times 0. 196 plus 9 times 1. 196 plus 9 times 2. 196 plus 9 times 3. And I get 223, which is a remainder of 3. Let's try 4. 196 plus 9 times 4. I get 232. That's a remainder of 2. Let's try 5. 196 plus 9 times 5 gives me 291. Let's try 6. 196 plus 9 times 6 gives me 250. So the check digit here is 9. And that concludes crazy clocks and checking out bars.